Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm now going to answer a question from the Cambridge Sue Pemberton textbook from International A-Level CIE Pure Mathematics P1. This is from Chapter 2, Functions, on page 54, Exercise 2E, Question 5. One of my students has requested that I answer this question, so I will do so. This question is all about transformations and, in fact, translations of graphs. This is a cubic graph, has equation y equals x plus 3, x minus 2, x minus 5. Write in a similar form the equation of the graph after a translation of 2, 0. So translation of 2, 0 is basically a horizontal translation of 2 units to the right. Horizontal translation of 2 units to the right. That's what it is in words. Okay, and that's represented, like, for example, if you have f of x is equal to this, x plus 3, x minus 2, x minus 5. Now this would be represented by replacing the x with x minus 2. Okay, it seems a bit weird that there's a plus 2 here and there's a minus 2 there, but that's how this works. If you replace the x with x minus 2, then what's going to happen is you're going to end up translating this 2 units to the right. When it's inside the function here, okay, then it causes a horizontal translation, okay, and it's always kind of the opposite. So fx minus 2 will cause this to translate 2 units to the right. Okay, so what we can do is we can replace the x inside this function with x minus 2. If it was 0, 2, then we would just add 2 to the whole function. In this case, no, we have to basically replace the x with x minus 2. So wherever you see x in here, we're going to put x minus 2. So instead of this x here, I'm going to replace it with x minus 2. So I'll have x minus 2 plus 3. And then I'll have, instead of x here, I'm going to put x minus 2 and then minus 2. Instead of this x, I'm going to put x minus 2 and then minus 5. Okay, so what I've done is I've replaced the x's with x minus 2's. X's have been replaced by x minus 2, and that's how we will cause this transformation to take place. So let's just now simplify that. That's x minus 2 plus 3, which is x plus 1, and that's x minus 2 minus 2, which is x minus 4, x minus 2 minus 2, which is x minus 5, which is x minus 7. Okay, so you end up with, this is your new equation. They don't want to express it in the general form for cubics. They want to express it in this form, in a similar form, as already kind of factorized. Okay, so that's the answer to this question. Okay, very simple. You just replace the x with whatever's in the bracket. If the translation is for the x part, you replace the x with what basically the opposite. So if it says plus 2, you replace it with x minus 2. If it says minus 2, you replace it with x plus 2. Okay, the opposite. And we can see how that would work. And if we were to translate this, just imagine we were to sketch the graph. Okay, if we were to sketch this cubic graph, you would have something that opens, that goes like this, because it's a cubic, all right? And you'll have the roots will be negative 3, 2, and 5. Those would be the 3 roots, negative 3, 2, and 5. And if you were to move this 2 units to the right, it's going to, the roots are going to move to minus 1 and 4 and 7. You can see that 3 is going to become minus 1, the 2 is going to become a 4, and the 5 is going to become a 7, which fits in exactly what we said here. Okay, so let me just show you. We don't have to do this second part, but I'm just showing you how it works. So the original graph would look something like this. You would have your, x-axis. Okay, you would have your 3 roots. In the original graph would have been when x minus plus 3 is 0, so x, that's going to be negative 3. When x minus 2 is 0, that's going to be a positive 2. And when x plus 5 or x minus 5 is 0, that's when x is 5. Those would be the 3 places across the axes, the x-axis. And then you can draw your y-axis up here. Okay, the y-intercept would have been what? It would have been 3 times negative 2, which is negative 6 times negative, it would be plus 30. Okay, now, if you were to translate this 2 units to the right, okay, by the vector 2, 0, that means everything shifts 2 units to the right. So the whole graph will shift in this direction by 2 units. Okay, so you'd end up with something like this. That would be -1, that would be 4, and that would be 7. And if we would try to write the equation of this after that, okay, that's going to become x plus 1, x minus 4, and x minus 7, which is exactly what we had there. Okay, so we can see that that works fine. And this would be 28, right? 7 4s are 20, so close to that 30. Okay, good. So that's exactly how that works. You don't have to show the second bit. I'm just showing you how it fits in with actually moving it 2 units to the right. Okay, so it says 2, 0, you replace the x with x minus 2. If it said -2, 0, you replace the x with x plus 2. If it said 0, 2, then we'll just add 2 to the whole function. If it's the y coordinate, you don't do the opposite. You do the same thing, right? Because you're going to add 2 to that will cause the whole thing to shift upwards by 2 units. But this is a horizontal translation of 2 units to the right. So you just basically replace the x with x minus 2. Okay, this causes this transformation, this translation. Okay, so that's how you can understand this question number 5. I hope that was clear. Any questions you have from this book or from the endotopic worksheets, or from generally from the work that I set, you're welcome to ask me anytime. Thank you for watching, and see you soon. Other questions from this particular chapter 2 of functions, you can find in the playlist over here. As I answer more and more questions, you'll find the playlist will start to fill up. Other questions from functions in general from Cambridge, P1, you can find in the playlist over here. You can subscribe to my channel by clicking on this link, and the video here will tell you how to navigate my channel to find things which might be relevant to you. Thank you for watching, and see you soon.